Welcome back, everyone. And today we are going to continue on the topic of Terraform and to be more precisely how to run it from the pipeline. But first, before we dive too deep into this one, let me tell you a story. So, when I just started my career, actually I didn't know about the pipelines at all, and I didn't really believe in them therefore. But one day, when I was working, and actually after I changed my job, the pipeline beat me, and after that, I pretty much became a strong believer. And now I try to convince everyone that if you want to make any change to your environment, to your code, to your application, it should go through the pipeline and never ever ever through the manual process. So I'm very sorry that I showed you last time in my Terraform 101 that you can run Terraform plan and apply locally from your computer. And now I'm going to fix this misunderstanding and I will show you how to do it in a proper way. But first, here is a view of what I have. So I have my Terraform 102 repository, and I created the rule set as I showed in the last shot, actually for Azure DevOps, but it is really similar for GitHub Actions. And over here I have a rule set main, which is enforced, so it is active, and I am targeting the default branch, and I require the pull request before it is possible to merge. And what is more important, that I require a minimum of one approval to get it done. With that, let's jump back into the code. So the Terraform code that I have over here, it is exactly as it was in my previous video, but now you have a link to the GitHub repository if you scroll down to the description. And over here we can make some changes. So for example, I want, and as you can guess from the README, at the moment I already did some changes. So let's say that we want to do some changes. And at the moment I am on the main branch and I have some changes. So let's try and commit this just to see how it will work. And git commit and git push. And as you can see, it is failing though. That is good. That's what I said in my last video, that we want to protect our main branch because we want to deploy to our production environment in this case. So what we should do instead is to check out demo, and that would be my branch. And let's git pull, git, and let's make some sourcing changes. Some changes again, and git add, git commit, and git push. So with it, as you can see, we are able to push to a separate branch that I call demo. And now let me tell you about the pipeline that I added. This is something new. So it is available on the GitHub workflows, and this way you should put all of your workflows or pipelines for the GitHub. And I hope that you know that already, and you don't need to have more information about this. But basically, what's going on over here is that this pipeline, it is triggered on pushes to the main branch, which are restricted by default and can be created only through pull requests. And also we run this pipeline on a pull request as well, and a pull request targeting main branch. Then I am still using the AWS, and I have some settings how to push it into the AWS from the code. And the more interesting part of it is that we are actually using the Terraform code to push it. So we set up Terraform with some version of the Terraform that I stick to. Then we use the Terraform wrapper because we want to have standard output available, and I will show you that in a second. And then we just configure the Terraform with some sort of a backend config. Here, let me take a slight detour, and I will show you the backend for the state config. And pretty much I am saying that I am going to use the bucket of Terraform 102 state, and I'm using the key, so the name of the file where the state is saved, it is state.tfstate. The interesting bit and the change to the Terraform code is now we have a remote backend, which is of a S3 origin. So the state file is going to be saved to a bucket on AWS. And to be more specific, it would be to some bucket with some random name over here, which would be overridden when we configure it through this. So that would be the bucket. And we have a key which would be once again overridden to something else that is over here. The key is state.tf file. Which is more interesting is that we are going to read this bucket so we know in advance and we hard code it over here that the region for the bucket is US East 1. And even more interesting, and that is something semi-new for AWS right now, uh, AWS provider, is that we use a log file. So there is no need to create a separate DynamoDB table, as it was the case before this change, and to log the S3 key for all of the changes. And instead, now it is possible to just use a separate log file inside that same bucket that will log the backend pretty much. So no two changes can be implemented in parallel. That is something new, as I said, that was provided by AWS backend provider for S3, and I highly recommend you to start using it because it's much easier to set up and maintain. And the rest is pretty much the same. Okay, with this, so we initialized the Terraform with the correct backend code for the bucket where we will store the data state of the Terraform. And after that, we just do some basic validation and formatting check. So the Terraform code should look pretty. And on top of that, it should be a valid Terraform code. Additionally, you can, and I highly recommend you to implement something like a TF or actually it is a trigger check over here. And if you will stick long enough with my channel, I will create a new video about implementing Tree for Terraform code and actually for the backend code as well soon, and I promise that. And next, we can run the plan command. But over here, we have a condition that the plan will be executed only on a pull request. And if it is not a pull request, then nothing will happen. And the command to run the plan is just pretty much run Terraform plan. And after this, we want to update the pull request, and I will show you that in a second. It's basically the workflow that I want to enforce for those changes. One user creates a change and then opens a pull request into the main branch. The workflow will start working and going through that code. Then, because it is a pull request, it will run plan and it will update the pull request with a comment of what the plan is. So someone who reviews the code and that change, they can verify that the change is actually valid and they can see what is going on. And after that, we just can finish up if the plan fails. But if we don't run the plan, so if it is actually push into the main branch, we can run Terraform apply, and over here I am just auto-approving it, so all of the changes to the main are immediately deployed to our environment. And if there would be multiple environments, and that's once again a topic for a different discussion, all of those changes would be propagated into your dev environment at the very least immediately, but possibly to production environment as well. Okay, with that, I am going to show you how it works. As I said, that we pushed it to the demo branch, and if we go to it's a selector Terraform 102 code, and I'm logged in as another user over here, we can create a new pull request, which would be from the demo into the main branch, and the changes are actually, they don't really mean anything, it's only to show you the process. And you saw it that direct pushes to main branch are forbidden. So when we create this pull request, we will see immediately that actually, first of all, that the review required and at least one person needs to review. That's why I have my incognito mode with one account, and then in my another window I have my other account logged in. And yeah, the merging is blocking, but on top of that, we can see that the action is started by itself right away. And we can see that it is actually doing all of those steps that I just showed you in code. And the most interesting one is that it is running the plan command, and we can see that it actually wants to create this resource for the AWS EC2 instance. If we will go back to our pull request, we can see that there is a status of the format and validate saved into the comment, and on top of that we have that same plan that we saw in the pipeline itself. So it's easy for someone to review and see what will be the changes. And now, as I said, in another window where I logged in as another person, we can go to pull requests and see that there are some readme changes. It's an open pull request by this guy. And this person who is doing the review, they can review the plan, they can see that everything is good. And because of that, they can assign themselves as a review, for example, and yeah, make that change to review the change and say that, yeah, it's looking great. I always wanted to have this change implemented. And then this person who is doing the review or the other person who opened the pull request itself, they can finally happily update the merge requests and commit it into the main branch. What will happen now with this change? We will see that actually we merged the pull request number 3, and because of that, the pipeline from the main is triggered. And in this pipeline from the main, we actually going to run all of those same steps, but Terraform plan and the script to update the pull request, those are actually skipped, and instead we go straight to the apply. And over here, we can see that yes, of course, it will display the plan, but this plan will be immediately auto approved, and the change will be implemented, and this AWS instance is created after 13 seconds. So pretty much how we saw it on my previous video when we ran the same thing locally. And now if we would go to the AWS console and refresh to see the number of running instances, we will see that the hello instance is yet again created, and it has some public IP address, and yeah, it was just started 1 minute ago, more or less. Okay, so with that quick demo of how the pipelines work in terms of the Terraform to deploy to AWS, I hope you have been bitten by the pipeline fever the same way as I did was. And now you will be doing that in the same way. So you will be running the pipelines left and right, up and down, and all of the time. And I really like it. So hope you enjoyed this video, and please like and subscribe to my channel, and see you soon. Bye.